Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to our second lesson on rational functions and their graphs. Last time, we learned about how to find the domains and asymptotes of rational functions. Today, we will practice sketching the graphs of rational functions. Are you ready? Let us begin by going through the steps for sketching the graph of a rational function. Start by reducing the function to its lowest terms and check for any open holes in the graph. Find the x-intercepts by setting the numerator equal to 0. Find the y-intercept by setting x equal to 0. Find all of the asymptotes if there are any. Determine the parity, that is, whether the function is even or odd or neither. Use the x-intercepts and vertical asymptotes to divide the x-axis into intervals. Choose a test point in each interval to determine if the function is positive or negative at that interval. In this way, we can see whether the graph approaches the vertical asymptote in an upward or downward direction. Finally, sketch the graph. Except for the breaks at the vertical asymptotes or the cusps, your graph should be a nice, smooth curve with no sharp corners. Let us try an example together by sketching the graph of this function. This function cannot be reduced any further, so there will not be any open holes on its graph. The function has no x-intercepts, nor does it have any y-intercepts. It has a vertical asymptote at x equals 0. It also has a horizontal asymptote at y equals 0. We are getting a good idea of how this graph will look now. There are no oblique asymptotes. The function is odd since its exponent is an odd number. Now let us find and plot several other points on the graph. We can do this by making a table of values. Finally, we can draw our graph. We plot our points Then draw curves through the points, approaching the asymptotes. There, we have successfully graphed a function together. Students, are you ready to graph a function yourselves? Please select a partner. Working together, follow the steps that we have learned and sketch this function. You may get started as soon as you are ready. Good luck.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. I hope that you worked well with your partners. Let us check your answers together. The function cannot be reduced any further, so there will be no open holes on its graph. Its x-intercept is 0, 0, which is the same as its y-intercept. The function has vertical asymptotes at 3 and -1, and a horizontal asymptote at 4. There are no oblique asymptotes. The function is neither even nor odd. We can check this by taking a test point. For example, f of 2 does not equal f of negative 2. And f of negative 2 does not equal f of 2. Next, we must draw the table of values. Remember, we already know there are asymptotes at x equals negative 3 and 1, and that y is 0 when x is 0. Finally, we can plot the points from our table and draw our graph. Does your graph look like this? I hope that it does. If not, collaborate with your partner after the lesson and double-check your work. There are certain conclusions that we may draw from this exercise. If a rational expression is in lowest terms and x minus a to the power of n is a factor of q of x, then the graph of f goes in opposite directions about the vertical asymptote x equals a when n is odd. Similarly, the graph of f goes in the same direction about the vertical asymptote x equals a when n is even. It takes a great deal of practice to become proficient at graphing functions. We will try to graph a few more now. Are you ready? Here are 3 functions. Do your best to graph all 3 of them as accurately as you can.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Hello, students. There were many steps to follow to answer all three questions. Let us check over your answers now. The first function equals negative x over x squared plus x minus 2, for x cannot equal negative 2 or 1. The intercept is at the origin. There are vertical asymptotes at x equals negative 2 and x equals 1, and a horizontal asymptote at y equals 0. This table of values will allow us to plot the points of our graph. Here is the resulting graph of the function. The next function has y-intercepts at 0 and 3 over 2. The x-intercepts are located at 1, 0 and negative 3, 0. There is an oblique asymptote at y equals x plus 4 and a vertical asymptote at x equals 2. These properties define the graph so well that we do not need to construct a table of values. Here is the graph of the function. In the last function, x cannot equal 3. Since x cannot equal 3, f of x equals x plus 3, except that there is a hole at x equals 3, y equals 6. No need for a table of values here. This is the graph of the function. I hope that all of your graphs look the same as mine. Great work. Today, we have learned the steps for sketching the graph of a rational function. Until next lesson, thank you, teacher. Thank you, students.